So now here we have a look at your nutrient cake. We're looking at nitrate concentration, dissolved nitrate concentrations. The top image shows you the surface distribution. So you have a nutrient cake you cut along the surface, and this is how it looks. What you can identify here is, in terms of the colors, purple means nothing, zero, and yellow to red are the regions where you have high concentration. And you can identify straight away all the subtropical gyres. Very, very low nutrient concentration. Okay? Very low nutrient concentrations because the Ekman pumping actually moves water, displaces water down. Okay? On the other hand, you can see regions where you have high concentrations. And one example here is the Southern Ocean, south of 50 degrees. South, okay? Southward from there, you can see. And that's actually an upwelling region where you get the Ekman suction of North Atlantic deep water. It's brought back to the surface. But I want to show you one other example. It's if you cut along the equator here in the Pacific Ocean, you cut along the equator, and then you get a nutrient distribution that's shown here in the lower graph, and you can see the separation between low concentrations near the surface and high concentrations at depth. And this transition zone between low and high, this is what we call the nutricline. And you can see in the eastern part is actually, it reaches to the surface, this nutricline, and this is where in the surface distribution you can actually see high nutrient. Okay. And this feature is connected to upwelling regions, both north and south of the equator. Okay, the Californian upwelling region and the Peru-Chile upwelling region, which was one of the most the most productive fishery regions. And on. So the reason why I show you that is because there's a link between the shape of this nutricline and the wind stress curl. So also changes in the wind stress curl can actually change the shape of these structures that you have in the ocean.